Native Cloud Foundation, it's a Linux Foundation project that was founded in 2015 to help and advance container technology and align the technology industry around distribution. So as we all know, Priyanka Sharma is the General Manager of CNCF, which CNCF now serves as the vendor neutral home of 100% of the fastest growing open source projects, including Kubernetes, Prometheus, and Embark. CNCF is the community of doers who enables open source projects, including Kubernetes, Envoy, Prometheus, and many others. It has got around 154K plus contributors to CNCF project and 163K plus CNCF meetup members. So we are and about CNCF Trivandrum, I don't know you all know Justin Koshinainan. He's the real person behind it. It is because of his interest and passion. Few of our friends started talking about starting a chapter here in Trivandrum. We started it a year back, but didn't do much because we all were having personal and professional commitments. Later on, Ebin and Vinayak from Strategy joined with us, and I think it is the mid of this where we started discussing about it, and now on April 9th, it is a reality. We are here for the first event. Thank you all the organizers. I just wanted to introduce the organizers. First is Vinayak Kumar. He is not here. He is supporting us from UK. He's the founder of Strategy. Strategy is the sponsor of this event. And he is a software engineer with a passion of Kubernetes and everything cloud engine. That is what he describes himself. And he is not here today, and he is supporting, as I said, he is supporting from UK. Thank you, Vinayak. And next is our Evin Babu. Evin is the chief organizer. He is the real person behind this event. He was running behind everyone to get things done. And my profession is head of operation at Strategy. And he comes from a background of engineering with a passion of everything open source. Next is Justin. Justin is a software engineer, very passionate about technology, Kubernetes, and cloud native stack. And he loves to solve problems using code. As I already told, he is the man behind this community. Thank you, Justin. And me, myself, Kavita Chakko, I have nothing to say about him. And next I just wanted to talk about Strategy. Strategy is the sponsor committee for this event. And Vinayak, who is the founder of Strategy, talks about Strategy as they are the proud CNCF member and KCSP, that is Kubernetes certified service provider. As a company, they love everything about Kubernetes and partner with companies to help adopt Kubernetes and be cloud native. Strategy is committed to supporting the growth of open source communities. Thank you, Strategy team, for sponsoring this event. And I just wanted to welcome and say thank you to Embark today and reliving members. They actually helped us to publish this event. So we will just start with the first session. The first session is on Kubernetes 101 for SREs and SREs. So the speakers are Basil and Akhil. Basil is the co-founder of COIT, an organization that provides work-oriented training programs on cloud-native tools and technology. Welcome, Basil. And Akhil Mohan, he's from Alliance Technology. He's an experienced DevOps engineer and system administrator, demonstrated history of working in the IT and service industry for around 10 years now, and he is skilled in Linux system administration, server management, Kubernetes administration, cloud administration, Terraform, and data center management. So, welcome Akhil and Jason.
Good morning, everyone, and welcome to the first session of our Kubernetes 1.1 session, which is targeted for DevOps and SRE colleagues. Myself, Akhil Mohan, I work with Linux Technology. I have been with the industry for about 10 years now, and hi all, thanks for joining. Myself I'm based and I'm the trainer and co-founder at www.milestone. Yes. So I'll just first give an overview about the topic. I hope I'm audible. Am I audible? Okay, so I'll give an overview about what we are going to talk about today. Just it's a Kubernetes one-on-one session for beginners, DevOps, and SRE. So there are 5 main topics. This is not only responsibilities of SREs, but this is what we are going to talk about today. First, we'll talk about managing container images, and then package application. I mean, how you can package Kubernetes applications in Kubernetes, and how you can deploy your applications to Kubernetes, and how we can handle the workload efficiently on Kubernetes, and observability, some monitoring, logging topics at the end. So we'll get started. So first we'll talk about managing the container images, how we manage the container images, and what are the best practices to do that. So you might already know we all use Dockerfile to build our application to container images. And it's very common practice today that whatever source code repository that you maintain, you also maintain a Dockerfile that will consist of all the instructions to build your application into a Docker image. Right? And after you build the Docker images, you always use a registry, and it is inside the registry you store these Docker images. You store them, you distribute them, because different people, different systems in your company want to use those Docker images and push the Docker images to the registry. So you need a registry to manage them. So we will talk about the Docker file, how you will develop your applications into a Docker image. So the example what you see here is a Docker multi-stage build. Basically, it consists of 2 steps. In the first steps, we build an application into, it's a Java application, and we are basically using a base image Maven, and using that image, we execute the Maven install command to create a jar file. Basically, that is an executable file that is commonly used for Java applications. And after creating this jar file, we are in the next stage, we build a production image, a optimized image, which would consist of the Java environment along with a basic Alpine image, a lightweight optimized image to which you will copy this jar file and make it ready to execute. So, and it's a good idea to do multi-staging when you develop your Docker file, because most of the time when your developer want to Docker development always happens in the beginning stage of your project, starting from your developers. And when they do that, you want to do a lot of things. You want to test your code, you want to do some security scanning, you want to do some building, the artifact building, and optimize production image building. And all those things you can actually put into various stages, and that would really help you do most of the things that need to happen in the initial stage of your development. So that's why multi-stage Docker file is much appreciated, and always use the Docker cache as much as possible. These are some best practices you can follow. And we use different tools to build the container images. There is Docker and there is Kenico. And if you are using a desktop or a computer, Docker build command can be used to build the container images. And if you are building the container images inside Kubernetes, then Calico is a best option, one of the best options that you can go with. And these tools can use the same Docker file, whatever you build for your applications. And these tools will build the container images, store them inside a container registry. And then that images are made available to different people and different systems that you have in your company. It could be a Kubernetes cluster or your CI/CD systems or your colleagues who want to push or pull the images to it. So we will talk a little bit about container registry. And there are different registry solutions available. You can go with the cloud or you can go with various options. You can set up registries yourself. And whatever registry that is set up, one thing is important: you make sure that it supports proper access control. So when I say access control, different people or different systems in your company want to push container images or pull them to the registry. So make sure that the registry support proper access control. And also it should be easy to integrate with other systems what you are using. You may be using some CI/CD system to build the Docker images, or maybe your colleagues are doing it from their laptops, and it should be easy to integrate the registry with the image building process, or whether it is the deployment process where Kubernetes want to download these container images. So we talk about what are the solutions available for the registry. There are different solutions, as you can see. This is only a few of them. You can either get registry as a service from your favorite cloud provider. It could be docker.io, hub.docker.com, I mean to say. Or it could be the GCR or AWS container registry. There are different registry solutions that your cloud provides you. Either you can go with that, or if you want, you can set up registry solutions yourself. There are different softwares that are available that you can set up and build the registry solutions. And next, that's pretty much I want to talk about the containers and container images. Now we'll talk about the complexities of Kubernetes, how complicated Kubernetes is, and how we will manage that complexity, right? So just take any application that you want to run inside your Kubernetes. So you want to create a lot of objects per applications. It could be deployments, pods, services, ingress, autoscalers, config maps, sequence. There can be a lot of resources per application. And especially you will be managing a lot of applications as well. Especially if you are using microservices, there may be a lot of microservice applications that you need to manage. And all these applications will have to go through these complexities of Kubernetes. So what you should do, or what is strongly suggested to do, is that whatever objects that you need to create in Kubernetes for your applications, you package it to a single file that would consist of everything that you need to create for your applications. It consists of secrets, config maps, autoscalers, or whatever that you need. And once you package the application, so you will package every application that you have in your company. You have 10 or 15 microservices, all of them you pack them into one single package, and this package will be installed onto the Kubernetes. So installing applications in Kubernetes actually means you are actually installing these packages inside the Kubernetes with various configurations. So the various configurations, as you already know, a company will have different environment. A laptop may have a local Kubernetes cluster like Minikube or K3D, or your dev environment, stage environment. You have different environments in your company, and every environment need to get their own specific configurations. What you change is you change configurations when you change your environment, not your package. Your package will remain the same. That will give a proper environment across all your identity across all environments whatever you manage for your applications. So the same package can be combined with the dev configurations to deploy the dev environment, and it can be combined with the production config to create the production environment. And like I said, if you have many applications that you manage in your company, you will basically manage them all in this way. All applications, you package them and you create different configurations for the different environments. That would simplify things to a very good extent. You don't really, if you did that, you don't really have to go through all the complexities of Kubernetes. And then these are two popular tools that you can use for packaging your applications or putting things together, right? Putting all the resources together that your application needs. The first one is Helm. Probably for developer it's much easier. And if you are using Helm on the first column, you can see it's a Kubernetes manifest for the pod. Kubernetes YAML file that you define for the pod. But as you can see, the name of the pod and also the name of the container are not defined inside the manifest. It is actually defined inside a different configuration file. And as you can see, the configuration file is pretty simple. It does not need to follow any kind of Kubernetes YAML complexity. And you can put this file inside a Git repository and your developer can directly manage it. They don't need your help to manage such kind of applications. And if you're using customized, that also has a similar workflow. Slightly different when it comes to the architecture, but it's all the same problem, the configuration management on Kubernetes. So if you're using customized, again, you don't use any templates, but instead you would use some manifest, the same manifest that Kubernetes need, and then you would customize it by means of some functions, using some customized functions. You would make changes to the base manifest and make them ready to various environment that you want to use. Right. So the next part, we want to deploy our applications to Kubernetes, and another thing what we would want to recommend is that along with your source code, you also include these manifest. Whatever manifest, it could be Helm charts, it could be customized configurations, or Kubectl YAML file, the Kubernetes manifest. You combine them with your Git repository, put those files also in the same repository what you manage for the Git. It is a suggestion, but it's not mandatory. If you want to separate the repository, that is also fine. But it's a good idea to combine them together because nowadays even developer want to install Kubernetes clusters on their laptop. So it's a good practice that you keep everything your project need in a single repository. And when you want to do a release, once you decided that you want to do a release, your application is ready to do the release, you tag them in Git and then your images are ready for release, and you can tag your images individually as needed, and you can tag your Docker images, you can tag your Kubernetes manifest also using Helm charts. Different options are available to do that. And once it is done, once your software is ready to be installed on Kubernetes, the next thing, it would be either you as an engineer or most probably it would be the CI/CD system that you have in your company which will do these installations to Kubernetes. And when you do that, there are two ways that you can follow. You can either use the CLI tools or you can use the GitOps tools. And when using CLI, different CLI solutions, as you might already be aware, there is Kubernetes Helm or customized commands that you can run from the computer, and then that would take care of the installations to Kubernetes cluster. Or you can use GitOps. GitOps is the best practice to do the deployments today, where you would make the modification to the Kubernetes manifest and store them in a Git repository. And then some tools that you have already set up in the company will pick up those configurations and deploy your Kubernetes cluster. So you will always work on Git. You want to do a release, you change your image tag in Git and you will make the changes and that's how it will be. Right? So this is the GitOps way of deployment. And next we'll talk about handling workloads, and I'm handing over the mic to Akhil, who will be explaining that.
Thank you, Basil. So basically now we have complete requirements. So now we manage these deployments. So when it comes to managing, the first thing which we have to look into is the scheduler. The queue scheduler actually is the brain behind the decision making. It makes decision making based on predicates and priorities. These are the terminologies which they use it. And predicates are basically filters which decide where your which all nodes can be selected for scheduling these pods. And these actually are based out of system constraint, like you may have your board which will require 16 GB. So this is actually a system constraint, like it cannot go into a node which does not have 16 GB of allocatable memory. So this is system-based constraints, and also there are also user-based constraints where you can say that you should run your workloads on, let's say, a machine which support GPU or a machine which support SSD. So these are user-defined constraints. So these are used to filter the nodes, and these are actually hard constraints. It has to be met. If it is not met, the nodes will not be selected or it will be rejected. So now you have a set of nodes where you could do your scheduling. So now it is up to the scheduler to identify which is the best node to be scheduled. So for this, you have something called as the priority policy. Priority policies are like soft constraints. They need not be satisfied always. Like you say that it would be nice if I could spread my workload across different VMs, which runs over different songs in a cloud. Then this is actually a priority. I'm sorry. This is actually it's actually a priority policy, which actually is a soft constraint. So if I'm not able to spread that, it is just fine. I can still go with the nodes which is available for me. So these are the two things which Queue Scheduler does. So you can see on the top left, those are the predictives which are available in Kubernetes, and on the right you can see the priorities. So it's something like you filter the node first, then you provide some kind of scoring based on what are your preferable priorities, and then you do a sort. And then you take the node which has the maximum score, right? So that is how the node is selected. And there can be cases when the scores can be same, right? So in that case, a round robin option will be selected where just randomly placed onto different nodes. So when talking about Kubernetes, actually Kubernetes provides a lot of flexibility, and even your cloud providers provide a lot of flexibility. If you are not using those flexibility, I think you are not doing much with your Kubernetes. So one option by which you could make use of these flexibility is by scaling your application, your cluster, etc. So that is where the scaling workloads comes into picture. So you have, from an infra perspective, you have cluster autoscaler, and from an application point of view, you have your application autoscaler. Project, usually all of you might have experienced this. You always start with manual autoscaling. How it works is like when you start a project, you might have only a few bunch of applications to manage initially. And it's quite easy to have some 3 or 4 nodes to schedule them. But as the project grows and more applications get migrated, or more and more applications coming into your project, then it becomes a problem for you. You see pods which are not getting scheduled for a long period of time, and you have to intervene and manually scale up, go to your cloud portal, you have to scale up your node pools which are associated and things like that. And then things starts getting problematic. That is when you can look into the cloud autoscaler. So cloud autoscaler actually provides you the flexibility. So whenever there is actually a pod which comes into a waiting state, Kubernetes and cloud provider acts together, and the cloud provider provides you provisions a new VM for which into which this particular port can be scheduled onto. So yeah, so but one thing to notice in here is that since there is a new VM that is getting provisioned, there might be a delay. So you should be aware about this particular delay, and your application should also be okay with this. Some cases, what people also follow is that they have some kind of pause pods, which actually has these, which use the same resources as that of your node, but which will be having a less priority. So whenever your applications are running, additional node is also spin up, and these pause pods are scheduled into there. And whenever your application requests new ports, you should ensure that these ports have more priority. And when these ports comes up, it kicks out, the script schedule kicks out the port which has less priority, and it will be scheduled. By this, you could avoid some delays, but you need to be aware that yes, you can expect certain delays due to this provisioning. So the next thing which we could also do, we saw that how we could do these tasks from a point of view, and now let's see how we could do from an application point of view. So think about a situation where your application resources are not quite sufficiently provided. There are two ways by which you could handle this. One is by increasing the number of replicas or the number of port counts. This is one method. You see there is an increase in requests coming in. You can increase the number of replicas and save that. And once the request has stabilized, you can just remove the extra ports and then come back to your normal replica. So this is what a horizontal autoscaler does. And there is another option. What you can do is that if you have a single port, if you have a port which has certain requests, and you see that your resource utilization is quite high over a period of time, then what Kubernetes also can do for you is that you could monitor this using metric servers and come up with a best possible targeted resource for you, and Kubernetes can assign these resources into a new port and remove the old port which the low resource. So this is called as vertical port autoscaler. So one thing to be noted in here is that in vertical port scaler to work, you should have preferably more than one replicas, because as I said, it actually creates a new replica with this recommendation and removes the old replica. So if you look at the workloads, if your main aim is to tackle the spikes in your resource, then it is always good to use SRE for that. You cannot use vertical autoscaler because, as I said, spikes are not being handled by vertical autoscaler. So what a vertical autoscaler does is that it looks for a period of time, and only based on that it decides on the autoscaling decisions. So there are also other extensions available for these horizontal autoscaling. The one which I love is KEDA. KEDA is actually an event-driven application. It provides you with different scalars. What you could do with these scalars is that, say if you have a Prometheus, you can actually write a query, and based on this query you can scale, right? This is possible using KEDA. Another thing which could also be is that you could monitor a queue, and based on the queue you could scale the replicas. And maybe also another option is that you have Postgres scalars where you could run the database queries, and based on this query you can actually scale up your application. So those are cool features. Please check that out. So you know that Kubernetes is a distributed system. So things does not happen in one particular area. It actually is a distributed across different ports and different services, and which brings up complexity in the Kubernetes as well. So it is quite important for us to know what is happening within the system, what actually which service actually is processing the request, where is the data flow happening, how is the data flow, and things like that. The reason is that things can go wrong anywhere in these pipelines. So it is our requirement as a SRE or DevOps engineer that we know what happens, where it happens, and why it happens. So these are the three questions as a SRE or DevOps engineer we have to address. So we have three pillars of observability which Kubernetes offer. The first one is the logging, the tracing, and the monitoring. Let's look at the logging. What is the logging? So let's look into logging with one of the tools which is popularly used in Kubernetes, which is the EFK stack. So if you look into the EFK stack, you have different Kubernetes nodes, and you have something called as Fluentd, which I'll be coming to in a moment, and you have Elasticsearch and Kibana. So that is why the name EFK, Elasticsearch, Fluentd, and Kibana. So what actually is Fluentd doing? Maybe before that, why would we want a centralized logging like this in a Kubernetes environment? You know that Kubernetes is quite dynamic, and pods comes and goes at quite regular intervals, and if the pods are deleted, the logs are also lost. So it is important to know what actually happened at that point of time, even if the pod is not available. So this is one reason why you need this centralized logging. And second, maybe that as it is a distributed environment, it's quite difficult for you to look into different application logs using kubectl, right? And it doesn't make sense also because to have a look into different logs. So this gives actually a Kubernetes view where you could filter for logs for a particular time period, and it provides the logs from all the services, which is a great feature to have. So these are the reasons why we would require a centralized logging in Kubernetes. So as I'm coming back to the slide, as I said, Fluentd, what it does is that any containers which are running on Kubernetes write the logs onto the underlying VM on a location called as var log containers. So Fluentd is able to process these logs, watch these logs, and process these logs. Fluentd also provides aggregation to your log. Aggregation in the sense that if you have to extract out the log levels from your log, or maybe if it is an Apache log and you have to get the, let's say, what is the code you got? Was it a 200? Was it a 501? Whatever HTTP code did you receive? So these details are available in your log. You could extract it out of the log as key value pair by using Fluentd aggregation. I will let you know what you can use it later. And what this Fluentd does is that it forwards these requests onto a central database called Elasticsearch, which is kind of a search tool which stores data which are received as JSON. And this is extremely powerful tool. It could actually search out and provide you results from millions of logs with a matter of no time. And Kibana is actually a visualization tool. It is actually Kibana where you log in and see these logs, and you can actually what you can say, you can work with these logs actually. So as I said, I talked about aggregation, right? Like it's possible for you to take the log levels and things like that. So you could use it in Kibana for creating dashboards or creating a search and things like that. So that is logging for you. And as I said, this is not only the only available tool in CNCF landscape. You have other tools as well. These are some of the tools which are listed in CNCF. You could also check into it. My recommendation is that check at least two tools before deciding which one you should go with. Okay, now the second question is that, as I said, yes, we have the logs available. But how will you relate it to the data flow? So you might have the logs, but it's not possible for you to identify how it's related, right? You cannot tag it to any data data path or something like that. So for that, actually, what you do is you have something called as trace. Trace, what it does is that these are it's not out of box available in Kubernetes. You have to use external applications. So if you are using a Springboard, you could use something called as Fruit, which provide this functionality. What it does is that whenever there is a where there is a request which is passing through Kubernetes, when it is loading, the trace tool will add unique characters to these logs such that these characters are transferred to the next application when this data flow happens. So this is commonly achieved by something called as trace ID and span ID. So if I have a front-end application, might not be only using that application, right? I may be writing something on a database. I may be say running reports, but actually happening in some other application. But these are related. So when I do that and I get an error, what happens is that I can find the initial log, and from the initial log I could get the span ID or the trace ID, and I could use it in Kibana, and I could search it further. So I could trace it further, and how I can do it, I can just paste the trace ID onto my Kibana, then it will provide me with details of all the associated logs for these traces, right? Which is great. I need not have to spend much time or things like that. So that is also something very important. I don't think it is up to the SRE or DevOps engineer, but as an SRE and DevOps engineer, you could recommend it for your application team. So as I said, these are some tools which are available. I think some of you might have heard about OpenTelemetry and Jagger, and maybe if you are using Springboard, you might have been aware of Sleuth. Okay, now let's look at log monitoring. Now we know that we know what the problem is, right? Maybe it is also required to identify why it happened, right? It could be that the CPU resource was high during that time, or it was that number of requests might have been high during that time, and things like that. So let's look into the logging, also in a similar way, by one of the tools which we have, which is the Prometheus. So in the Prometheus architecture, the central brain is your Prometheus server. So if you look into the Prometheus server, you can see that there are three components in Prometheus server. The main component is the time series database, which saves the metrics. So metric is nothing but it is kind of a representation of what happened in the data format at that particular point of time. Like what you have in your load average, right? It shows you the data for 5 minutes, 10 minutes, and 15 minutes. And similar to that, metric is similar to that, and it gives you a data of what happened at that particular point of time. And Prometheus save it as a time series database, and into the time series database, and you have a hard disk or SSD data where it is saved onto. Then you have your HTTP server, which allows you to query these matrices which are available, and then you have the retriever, which actually does the job for you. It goes and collect the metrics for you. So one thing to be noted with legacy monitoring tools is that legacy monitoring tools uses a push method. Like you have a agent which is running on your nodes, which collects the node details, application details, and then push it to the monitoring system. So this actually can cause issues onto your network and cause issues onto your monitoring, because monitoring does not have control on what's coming to it, right? So it's possible that it gets distorted, or you might get regular issues. So unlike those legacy systems, Prometheus actually pulls the metrics. So it decides what to get and when to get it. So by this you have certain advantages over the legacy systems. So let's look at other components as well. So as I said, it always pulls data, but sometimes it might not work out. So say you have a short-lived jobs, right? It just runs a batch job and then the code gets deleted. So it might not be possible for Prometheus to scrape it quite quickly, right? In that scenarios, you use push method to some extent, but you use something called as push gateway, where the short-lived codes or back jobs pushes the detail on the push gateway, and then which will later get stored onto Prometheus. And you also have different job exporters available. So example like if you have some OEM tools like Zookeeper, Kafka, where if the metrics are not readily available, what you could do is you could use a Kafka exporter or Zookeeper exporter, which actually looks into the JN export and fetches the detail and provide it to Prometheus. So those are exporters. Now on Kubernetes, you have something called a service discovery where you provide the annotations to the services. What these annotations will provide Prometheus with is that it will provide whether it has to scrape this particular service or not. If it has to scrape this port, it should look into. So these like that are provided by the service discovery. And now we have this monitoring, and it will also be interesting to look into spikes and issues. So for that, you have something called as alert manager, where you could provide different queries. Like for example, let's say if my container restart of a code is greater than 0, I need to alert, right? So that is being handled by alert manager. So if you want to look into these alerts, you have two options like Prometheus provides Prometheus URI, which queries which you could use. You could use from QL to query onto Prometheus server, and if you are interested in what you can say visualization and to have good dashboards and things like that, you could look into Grafana, which actually is a very good tools. And Prometheus, as I said, can be integrated into other tools as well. Kira is one of them. So these are the monitoring tools. There are a lot in the landscape. You could also look into it. One thing which I would also like to mention is that Prometheus is able to pull from Prometheus also, and the Prometheus instance also. This is called as federation. So if you have multiple clusters and you would like to have, let's say, data from these clusters for about 8 hours, and it's not necessary that all data is required for a long term. And then you could select few matrices and then pass it to a centralized Prometheus for a more long duration. But even then, at some point of time, that central Prometheus might also get issues due to this high amount of data. So in that case, you could look into Cortex or what you can say TAM, where it actually uses downsampling and cloud storages like S3 bucket or Azure storage accounts to store data, and it can be saved for like 6 months, 1 year according to your requirement. So you could also look those tools as well if you want. So thank you for your attention. Any other questions?
Any questions?
Yeah, so I will correct this basic. Like earlier we discussed about the deployment strategies in the first series, right? So as you know, we have kind of a grouping in the gallery deployment, etc. But in Kubernetes side, the deployment is happening if you have the managed service like EK or EKS. So the replica is actually pulling you the new once that deployment configuration is ready. Otherwise, it will be keeping the old replica. So, is there any kind of a strategy like grouping deployment or can deploy the Kubernetes deployment strategy?
Yeah, there are various deployment. there are various deployment strategies in Kubernetes today. I think we didn't cover that a lot, but yeah, there are various methods. One is blue-green, canary deployments, and by default in Kubernetes it is rolling update. I hope everyone is aware of. And there are ways to do. I mean, you can strategize your deployment, and there are different tools that are available where you can define your deployment strategy also as a code. For example, for blue-green deployment, it's a different strategy altogether. If it is Canary, there are tools available such as Flagger or there are Argo rollouts. There are tools where you can actually define your strategy inside a YAML file, just like a normal other Kubernetes manifest, and then you can again implement the DevOps practices or whatever way that you want to do. So what that means is a fixed number of when you do a deployment, you would be deploying only to some 10% of your user or 1% of your user, not deploy everyone. So there are ways available, and that can also be written as a Kubernetes manifest. And you need to use different tools such as Flagger or Argo rollouts that allows you to define the strategy in the file. They are very popular tools, and that's how the recommended way of doing the incremental delivery in Kubernetes using some tools such as Flagger or Algorithms.
That is one way. I mean, your Kubernetes also need to be aware about what you wish to have, right? So it's always good that if you have a rolling update, you have multiple replicas, so that your service is not affected. And maybe that let's say you could also have something called as the pod disruption budget, which lets you know say that what you can say minimum available or maximum unavailable pods, so that Kubernetes is aware about how it should maintain the workload and how many pods it can delete when there is a planned interruption or entry interruption. So it's actually a combination of what Basil said and how you want it and how you can achieve it using Kubernetes.
We're talking about application obviously, right? The horizontal vertical scaling. So spike is sort of the example we said it's cannot be around vertical methods. So CPU will be right? So spikes will be the layer. So what are the scenarios where this horizontal will not be applicable?
Yes. Quite frankly, I think not much in production environments you have vertical auto scaling. I can point out one way which you could use vertical auto scaling along with horizontal auto scaling, let's say. Or with any environment for that matter. What you could do is that actually vertical auto scaling has three components: the admission controller, then there is a updater, and then there is what you call as a recommender. So recommender actually looks into the port history and gets the information about what would be the recommended value for the request, and it provides you with that. And the updater updates that onto your port, and admission controller use this to control the admission of the new port with this new request, and then it does the scaling, right? So that's how it works. So what you could do actually in your environment, usual cases in dev environments, what happened is that you actually goes up not providing enough resources, or you goes up providing over resources. So it's okay to I mean, if it's issue development, it's okay to have to over commit on your request. But still, what you could do as a best practice would be to run the virtual autoscaler in a recommendatory mode. Means you can just turn off the update option, right? And once you do your testing in your development environment, this recommender looks for the codes, and it can provide you with the correct recommendation for your request. So this is one way you could use a particular autoscaler. And I'm not quite aware about how running in production because I am experiencing that.
whatever is key, how we can able to use for tracing and application. But I'm using in AKS.
To be frank, I'm not experienced with setting, but I have in my environment Smooth, which is similar, it's kind of similar, providing similar things. So what this Smooth provides in my environment is, as I have this centralized logging, it's quite easy for me if everybody uses the same kind of logging format, right? That's one thing which I would prefer as a centralized logging administrator. So Smooth provides that. You can just integrate your form according to the unified logging which you agreed upon in your organization, and it makes my life easier because I just only have to write the regex in fluently once and whatever new application comes. So in addition to that, Smooth also provides this trace ID onto your trace ID and span ID onto your logs. So as I said the scenario before, when there is data transfer or request drawing information from the application, then these span IDs or trace IDs are also injected into these requests. If it's not getting spanned, then it won't be it will not be available. So what you could do is you could aggregate it using Fluentd, and then based on this you could optimize your search to issues, right? I mean, you know that okay, this is a front-end application, so request should obviously go into here, and you search the front-end application, and you find the log. Let's say it was a 500 error, right? You found the log, and from there you get the trace ID, right? You can again search for that particular trace ID, then it gives all the associated logs in other applications as well. So this is one way which we use tracing in our environment.
The developer also should be aware about impurities, or this can be achieved by
Actually, I think it should be a collaborated effort between application and SRE or DevOps. First, you need to enable or support it within your application, so there is some code change required for that. And your centralized logging or any tool which uses this should be aware about this and should what you say should get this configured within their application. So I think it's a collaborated effort for both.
And as you mentioned, like the auto scaling of nodes, so we in order to avoid the latency of creating a new VMs at that particular demanding condition, so we got like we can kind of a post node technology. Okay, post node technology means we will be keeping kind of a buffer. So how that is configured means when it is actually configured, the rest application support where it is actually meant to configure.
It's not actually a technology or something. It is things which developers, DevOps engineers does to tackle this situation. So it doesn't mean anything. It's just a dummy code which has the same resources as what is allocatable to your node. So if you have key nodes and let's say you have auto-scaling and there is a possibility that new nodes will come up and you cannot have this particular latency for new node provisioning, then what people does is that they add this extra dummy code which has less priority. So you need to ensure that you have the right priority for your application. So when this application auto scales or it has a code which is in pending state, the queue scheduler just kicks out the one which has low priority because your one is the one which is high priority and gets scheduled. So that is one way people do or tackle these situations.
In the interest of time, I think we can take one more question, right? Any more questions? We will be getting chances to He is an AWS community builder, active member of other technology communities. His name is not among the DevOps community. I think you are familiar. And he is a facilitator for the Google Cloud Ready program at this institution. And he is a major league hackathon head at the university and secured 6th and 8th position globally in the year of 2020 and 2022 respectively. So over to you, Alexei.
ഇൻഡസ്ട്രി എക്സ്പെർട്ടിന്റെ ക്ലാസ് കേട്ടു. ഈ സമയം നിങ്ങൾക്ക് ആക്ട് ചെയ്യാനുള്ള സമയമാണ്. അതായത് വലിയ പരിപാടിയൊന്നുമില്ല. നിങ്ങളുടെ ഫോൺ എടുക്കുക, ഈ നമ്പറിൽ ക്ലിക്ക് ചെയ്യുക, കൊടുക്കുക, ക്വിസ് കളിച്ചു കൊടുക്കുക, അത്രേ ഉള്ളൂ. ക്വിസ് കൊണ്ട് ഉദ്ദേശിക്കുന്നത് നിങ്ങളുടെ ടെക്നിക്കൽ നോളജ് ചെയ്യുന്നൊന്നുമല്ല, ജസ്റ്റ് ഒരു ഇന്ററാക്ഷൻ. അതുകൊണ്ട് എല്ലാവരും kahoot.it എന്ന ഒരു പേജിലേക്ക് ആ ഡൊമൈൻ നെയിം ഒന്ന് കൊടുത്ത് ഈ ഗെയിമിൽ ഒന്ന് ക്ലിക്ക് ചെയ്യുക. kahoot.it. സോ ഇവിടെ ശ്രദ്ധിക്കേണ്ട ഒരു കാര്യം, ക്വസ്റ്റ്യൻസ് നിങ്ങളുടെ മൊബൈൽ ഫോണിൽ കാണത്തില്ല. ഈ മെയിൻ സ്ക്രീനിലാണ് ക്വസ്റ്റ്യൻസ് വരുന്നത്. ആൻസേഴ്സും ഇവിടെ കാണും, പക്ഷെ ആൻസറിന് റെസ്പെക്റ്റീവ് ആയിട്ടുള്ള സിംബൽസ് ആയിരിക്കും നിങ്ങളുടെ മൊബൈൽ ഫോണിൽ വരുന്നത്. സോ ആൻസർ ഏതാണെന്ന് ഇവിടെ നോക്കുക, സിംബൽ നിങ്ങളുടെ ഫോണിൽ വരും, അതാണ് സെലക്ട് ചെയ്യേണ്ടത്. നെയിം കൊടുക്കുമ്പോൾ ഫസ്റ്റ് നെയിം അണ്ടർസ്കോർ സെക്കൻഡ് നെയിം കൊടുക്കാൻ ശ്രദ്ധിക്കുക. കാരണം ഒരേ പേരുള്ള രണ്ടുപേര് വന്നാൽ അവസാനം കുറച്ച് കൺഫ്യൂഷൻ ആവും, ആർക്കാണ് പ്രൈസ് കിട്ടുന്നത്. അതുകൊണ്ടാണ് ഫസ്റ്റ് നെയിം അണ്ടർസ്കോർ സെക്കൻഡ് നെയിം. ദാറ്റ് വിൽ ബി ബെറ്റർ. ടോട്ടൽ 10 ക്വസ്റ്റ്യൻസ് ഉണ്ടായിരിക്കും. അതിൽ നിന്ന് ടോപ്പ് 3 പെർഫോമൻസിനായിരിക്കും സെലക്ട് ചെയ്യുന്നത്. അവർക്ക് എക്സൈറ്റിംഗ് റിവാർഡ്സ് ഉണ്ടായിരിക്കുന്നതാണ്. അപ്പോൾ ഇത്രയും പേരേ ഉള്ളൂ. പെട്ടെന്നാക്കിക്കേ, സ്പീഡപ്പ്. ക്വസ്റ്റ്യൻസിന് 10 സെക്കൻഡ് ആണ് ചെയ്യുന്നത്. 10 സെക്കൻഡിനുള്ളിൽ നിങ്ങൾ ആൻസർ ചെയ്യേണ്ടതാണ്. ഇരുപത്തെട്ട് പേരാണ്, 29 പേര്. എനിക്കും അതിൽ കൂടുതൽ ആൾക്കാർ ഇവിടെ ഇരിപ്പുണ്ടല്ലോ, അല്ലേ? അപ്പൊ എല്ലാവരും ഒന്ന് ഫോൺ എടുത്ത് പെട്ടെന്ന് ചെയ്താൽ നമുക്ക് പെട്ടെന്ന് ക്വിസ് കളിക്കാം, അടുത്ത സെഷനിലേക്ക് പോകാം. So I will repeat the instructions again. So you have to go to kahoot.it, that is the domain name. On the domain name, you have to enter the game. So once you enter the game, you will be getting a basic screen. Here you want to understand that the questions will be only on the main screen. You won't be able to visible the questions in your mobile. You have to get the correct answer from the main screen. Select a particular symbol for that answer and select the symbol in your phone. That means only the symbol will be visible in your phone. In order to give the name, you should give first name underscore second name, because there will be a confusion if there are similar names. In order to avoid that confusion, we will be using first name underscore second name. Top 3 performance will be selected and facts will be given. Come on guys, only 36 members, come on. Anyone have any doubt regarding how to get started the quiz? Anyone have any doubt? Hope you all got my instructions clearly. So 37 പേര് ജോയിൻ ചെയ്തിട്ടുണ്ട്. അപ്പൊ നമുക്ക് ക്വിസ് തുടങ്ങിയാലോ? ഓക്കെ, ആർക്കും ഒരു സ്വരമൊന്നും ഇല്ല. ഞാൻ ഒരാളും കൂടെ നമുക്ക് റൗണ്ടാക്കി 40 ലക്ഷം പോകണം. അതിലുണ്ടോ? അതിൽ ഒരാളും പോയിട്ട് വന്നാൽ നമുക്ക് ഉടനെ കേസ് തുടങ്ങാവുന്നതാണ്. അതിൽ ഒരാളും കൂടെ ഉണ്ടോ? കേസ് തുടങ്ങാം. ഓക്കെ, റെഡി? സ്ക്രീനിൽ വരും. ഓപ്ഷൻ നോക്കുക, കറക്റ്റ് സിമ്പൽ നിങ്ങളുടെ ഫോണിൽ ക്ലിക്ക് ചെയ്യുക. Which of the following services run on Kubernetes? 4 seconds, 3 seconds, 2 seconds. The correct answer was both of the above. That means Kubernetes and Kuproxy. 15 people got it right. So we are moving to the next question. So this is a scoreboard right now. Second question. What does the term elasticity in cloud refer to? 10 seconds. Thirty-four people got it correct. Still coming? Yes, leads. It's the first position with 1,866. So we are moving to the next question. Name are applied to dash. Five seconds. Yeah. 21 got it correct. The right answer is no. Still the same person leads in the first position. So we are moving to the fourth question. Each of the following runs on each node and ensures containers are running in a pod. Ten seconds. Thanks. So 17 got it right. Yeah, the Cyril Johnson comes to the first place. Fifth question. Kubernetes is not us. Ten seconds. Thanks. They got it right. An object that represents the node. So Cyril is the first and Charles comes to the second position. Sixth question. In Kubernetes, PVC stands for. PVC stands for. 15 seconds. Five seconds. Time for 22 got it correct? Correct answer is persistent volume value. Series, charge, and only are the top three performance till now. Let's move to the next question. Choose among the following, which are the characteristics of IaaS. 10 seconds. That is I got it right. So there is no change in the positions. So we are moving to the next question. Identify discrete, which is one for setting a global default for users. You have to identify the script. 5 seconds. 11 got it right. Only 3 comes to the first position. Charles stays in the second position. So we are moving to the next question. Second last question. In which directory can you store system user default files used for creating user directories? 10 seconds. Time, sir. Only 9 got it right. Still, there is no change in the first three position. So, we are moving to the last question. 10 question. Last question. Ten seconds. So 17 got it right. So we have successfully finished the quiz. So let's see the top 3 performance. Charles John, congratulations, comes in the third position. Second position, only B. And first position goes to Cyril Johnson. Congratulations to all 3 top performance and thank you.
So we will break for 10 to 15 minutes and we'll join back. He's a software engineer, very passionate about technology, and he loves to solve problem using code. Welcome, Mr. And we have Reggie Blair. Reggie is a tech savvy, senior technical architect, and now holds the responsibility of lead engineer at Backside Networks. Welcome, Reggie. Over to you.
implement the actual DevOps practices. So, a DevOps engineer role is to manage everything end to end, right? Make sure that whatever automation need to be done, it is done in place, and whether it comes to the project planning, project delivery, deployments, whatever it is, end-to-end role, right? That's what a DevOps engineer do. And when it comes to SRE, it's mostly they also do the same thing what DevOps engineer do, but their role is more to make sure that they takes care of the infrastructure management, make sure that the proper code monitoring and logging and tracing are implemented inside the practices, inside the premises and inside the applications and also the infrastructure. And it's availability, reliability, right? All those things need to be made sure on the project, and that's what SRE do. And there is not a clear difference actually, in fact, between a DevOps engineer and SRE. Some people actually call it, most of the people call it SRE, and DevOps is also a team. It's more like a teamwork, and it covers a lot. It covers starting from the development, from the project requirement till the code is in production. So yeah, I don't know if that is the perfect answer to that question, but yeah, generally they do a lot of things similar, and it all depends on the project requirement and the work that they are doing. And mostly it's all about making high availability, reliability of the infrastructure and the applications, and proper monitoring.
So I believe you are associated with the point or diagram. So, what services do they offer, and how you got into this point or diagram? What challenges you faced, maybe in your path to reach to this point or diagram? Just make it absolutely.
So yeah, thanks for the question. Yeah. So my company, we are into the company is Coit.io, and what we do is we build different courses which are completely made into cloud native technologies. And the reason why we exist is that we strongly believe that the market is not adapting the cloud native technologies as fast as it needs to be. So what we decided to do is we build some courses and implement the DevOps practices in a cloud native way. That would make we focus mostly on the developers ability for them to deliver things much faster. So what we do is we build different courses which are based on cloud native technologies, and I'm one of the trainer. I am also one of the trainer who build these courses. So yeah, that's why we exist. The idea is that build some courses and show how to work with the cloud native technologies for and implement the best practices on your project. Yes.
In your courses, we use more like open technologies or
mostly open. Whatever tools, most of the tools that we cover is open source technologies, but we also take care of the cloud, which is obviously costing money. Google Cloud, AWS, different cloud providers. Most of the courses are based on open source technologies, and it's more like a problem versus solution kind of courses that we do. For example, how a developer should be working, and what are the tools that they need in their laptop to implement the best practices, and do most of the things ship left, do most of the things at the beginning of the software lifecycle itself, or CNCG practices. It's like problem versus solution kind of. As of now, there are also 9 courses, and the tools include Helm, Customize, DevOps tools, RPC, and mostly Kubernetes and Google Cloud, AWS, and Scaffold, K3D, tools that developer uses, tools that CI/CD uses, Argo workflows, agreements, and again, one course contains more than one tool because it's problem versus solution. Yeah, CNCG we have two courses. One is Jenkins, and the other one is cognitive courses. Argo events and Argo workflow. We work creating the pipelines and that. So two courses are available. Yeah, my contact details are on the website. You can get it to.
Hello everyone. Sorry for the delay. Yeah, welcome to this session on Kubernetes overview for developers. So I'm Priji.
Just I got graded out to Kubernetes and CNCF projects. I'm not working now. I'm doing a new opportunity as well. Yeah, thank you.
So I work with a company called Backside where we have Kubernetes used a lot, containerization and stuff like that. So what we're planning to cover is just an overview of the different Kubernetes objects and a few developer tools and an overview of various components in Kubernetes and a little bit of overview about extending Kubernetes and custom resources and operators. It's just a basic overview of these areas. Kubernetes was built at Google and they open sourced it in 2014. So it's a platform for managing containerized workloads. So if you can containerize your application, Kubernetes can run it. And in Kubernetes, we have a cluster of physical or virtual nodes. It can actually support up to 5,000 nodes and maybe 300,000 containers. That's kind of the limit. And it efficiently shares compute resources and it provides automatic bin packing, which we covered in the earlier session about scheduler, right? So you have these nodes and we specify what resource requirements we need for running our application, and Kubernetes takes care of an optimal scheduling to put your application on the right node and make use of the node to its maximum. So that is automatic bin packing. It supports stateless, stateful, and data processing applications. So once you have your component built as a container, right? So Kubernetes, we don't directly deploy that container, but we package that in a resource called a pod. So a pod provides an environment for the container to run. So it specifies the environment. Several other things that the container or our application needs to run. So this pod can pack actually multiple containers too. And in a pod, each container share a network namespace, which means these containers can communicate with each other using different inter-process communication mechanisms and shared volumes. So that makes it possible for us to package a coherent set of pods, containers into a single pod. And again, we don't deploy pod directly, we can, but it's usually associated with a workload resource, such as a deployment. The workload is a Kubernetes application, and it has a controller associated with that, which ensures, for example, that the right number of replicas of the pod are running, and in case a pod fails, it restarts it. So some of the usually used workload resources are like deployment, which can actually do stateless services like a microservice or an HTTP host. A stateful set, which actually hosts stateful applications such as a database, a job that can do like a batch job, do and be done. Doesn't need to run forever. A daemon set, which actually runs on every node in a cluster. So once we have this code, our application packaged and deployed as a code, we expose the service or the functionality to a set of pods, right? And these pods, each one gets an IP address too. But if we consider deployment, which is stateless applications, and these deployments can have its pod restarted due to various reasons and have different IPs associated with that later on when it comes back, when the pod comes back. But if we want to access that service exposed by that pod through the port and IP address it exposes. This restart or reallocation of the IP can be problematic. That's where service come to help here. A service actually groups a set of ports based on the functionality it exposes. So instead of calling a port directly, we can define a service and then route the traffic or invoke that service, which will eventually route our calls into the right ports required. So depending on the replicas, you can have multiple ports installed, right? Or port started. So service will ensure that service will ensure that it gets load balanced and routed to one of the ports that actually given the service. The way it implements that mechanism is through a label and a sampler mechanism. So when we create a port, we associate certain labels with that, which later the service uses to associate or group them together using that to form the service. So that's how it was. This also enables service discovery because whenever we restart a port, depending on the label, it actually associates that port with the service. So that makes service discovery possible. And again, the service, in order to expose that to the outside world, outside the cluster, there is something called an egress. So if you look at a diagram, when I call is import, somebody reaches through the egress to the service to the port. That's how the routing would happen. This is a sample deployment spec. You can see, initially the kind is deployment, and then max labels specifies the codes that this deployment loops into, and then this template is the pod template. You can see the label there, and then in the spec you can see the containers that it's going to start. So this is a sample deployment spec. And Kubernetes, these are the key components when we install Kubernetes that get deployed. One, the key or the core component is the API server, which exposes the Kubernetes API, which allows us to query and manipulate the Kubernetes API objects such as pod. And then controller manager, like we discussed about the controller, right? Deployer has a controller associated with that, which ensures the right number of replicas of pod run. And so there is a controller process associated with different types of workload resources, and by default there are several of them that ships with Kubernetes. So there is a process that hosts all of them, and that is what the controller manager is. And cloud controller manager is an optional component, but when it is Kubernetes is in the cloud, that component is what interacts with the cloud APIs and facilitates the infrastructure and communication with the cloud APIs. etcd is the data store, persistent data store, which actually stores the state of the Kubernetes cluster. It has everything like the objects created, the replicas, namespace, all those things comes in there. Kubelet runs at the node, and it ensures that the code that we want to run at that node is actually, it receives a pod spec and spins off the pod in that, or runs the container based on that. Proxy deals with the network, networking, and the service communication mechanism that we discussed earlier. Proxy is a key component in that, with the routing of the traffic to services. And scheduler, we saw that in the earlier session already. It makes sure whenever a new pod is created, it ensures that it gets a node to run on, and it gets the right node depending on the configurations. So those are the key components. So it just development.
I think we need more interaction. So how many wants to run their application on Kubernetes? Raise the hand. And how many wants to run clusters as well? Yeah, I think the answer is positive. So that means everyone wants to run their applications or wants to implement an ecosystem for Kubernetes. But the problem with that is, when you get started, it is too expensive in the sense we need more compute resources to run the Kubernetes. Even if it is management services from different cloud providers, or even if it is self-managed Kubernetes clusters. So if someone wants to play with Kubernetes, or if a developer wants to run their application, or start getting with the Kubernetes related application development, we are having certain tools such as Minikube and Time, which will help us to run their applications, which is on the workstation. That means we can create a cluster of our own with certain specification which can run on the workstations. So there are two. Initially, it started with Minikube, but we are having a very good tool now called Time. Time is based out of Kubernetes in Docker. That is based out of a technology called Docker in Docker. Didn't. So these are two amazing tools which we can easily run your Kubernetes clusters, even for the development and for SREs as well. So for an application developer, it is very much hard to pack their applications, because if you want to run the Kubernetes, if you want to run your applications, for example, if it's a Java application, you may need certain export variables, you may need certain runtime configs, you may need a lot of things. So it is very, in terms of Kubernetes objects, it may can have deployment, it may can have services to export your service outside world. So there is a huge gap in that. So there is a need of packaging your entire application along with the Kubernetes manifestos. For that, we can use a tool called Helm. Helm is actually based off Golang. If you are aware about Golang development, you probably know about the certain packages from Golang. So it is based out of a text Golang package, which we can easily templatize our packaging of our applications into the Kubernetes. So it will be very helpful for each and every developers. And another thing is Customize. Customize is one of the native configuration management tool, which is actually based off of a protocol, not a protocol, a standard called JSON patch 6902. That means we can apply patches like edit, change, delete, everything on the JSON objects. Since Kubernetes objects are, when we are running our application, we mainly wrote the manifestos in Embark or JSON format. So we can make use of Customize to make our configuration more easier. But I would suggest, as a I've been into the platform engineering side, so I definitely suggest every platform engineer can use Customize to make your configuration very easy, because iWAS belongs to a team where we manage more than 40 clusters, which is self-managed. So currently also it is self-managed. So the entire cluster is actually DevOps. We operated each and every cluster with the help of these customers. So I believe that it is very much helpful for the SRE people who can love to run or DevOps. If you want to operate through the Git model of your clusters. So other than that, since for creating a Helm, or since we need to manage or attach or customize using the customized thing, there is a huge need of spending time on that, each and every developer. So for making the developers' life more easier, we are having certain other tools such as Scaffold and Draft, which it will do a lot of magic at the back end. So you don't want to worry about anything if you use Draft. Draft is one of the best tools. So Draft is actually from Azure. So if you use Draft, you don't want to see anything about writing these manifestos or most of the things which is usually managed by the DevOps guys. So you just want to focus on the application development, but with Draft, simple commands, so that Draft utility can help you to containerize and deploy the application code easily with the Kubernetes. So these are certain tools which can help and which will help the life more easier for the developers as well as the SREs. Thank you.
So we will go to an exciting topic. And Kubernetes, the real power is that it is very flexible. So extending Kubernetes, we can do at different dimensions. I think these are some of the key or high-level areas where we can extend Kubernetes. One is the kubectl binary. kubectl is the CLI tool for Kubernetes, which we use to interact with the control plane. So kubectl can take extensions or plugins to extend its functionality. We'll be going into details later, but that's one point. Then Kubernetes APIs access to the APIs can be it already comes with authentication and authorization mechanisms. But if you want to extend that, there are mechanisms for that by means of webhook. That is one other thing. And then we already saw some basic resources like or one other thing. Some other things we already saw. If we want to extend that functionality, we want to add our custom resource. That's also possible. Then controllers, we saw one like the one for deployment, right? So we can have our own controllers too and deploy them. Then scheduler, which is what takes the code and deploy or assigns a node for that. If you want to customize that component, it is also possible. There is a scheduler framework also that came out where different points in the scheduling, decision making process we can customize using webhooks. And Kubernetes networking is another area. For example, if we want to encrypt our traffic or something like that, we can have network plugins installed. And storage, is what when the persistent volumes and that kind of storage. If you want to come up with something new kind of storage device, we can have plugins to actually adapt that into Kubernetes. So these are some of the key areas, and if you look at that, there are three main mechanisms by which these plugins can be installed in the Kubernetes. One is webhook, and all these mechanisms, one of these techniques will be used. Is either webhook or a binary plugin or a controller. Controller actually accesses Kubernetes APIs in order to do this functionality. So controller is going to be a client of Kubernetes API. Webhook, Kubernetes API is going to follow out. So Kubernetes API will be the client of the webhook, and binary plugin would run on kubelet. So it will be loaded by kubelet or kubectl. So those are the three different modes plugins will actually be loaded. So we'll just look at extending kubectl with binary plugin.
Thank you, Bridget, for giving the overview. So, as Bridget already told, the main good thing with Kubernetes is we can extend Kubernetes of our own. So that is what the different cloud providers extended Kubernetes into that way. They can customize. We can customize many of the things in Kubernetes. So, how many are aware of kubectl? I told about kubectl. I am pretty sure that most of the people sitting here can know about kubectl. So if someone is new to kubectl, so kubectl is the CLI tool. It is just a CLI tool. So it is a CLI tool which can be run as a binary in our systems, which can be used to interact with our clusters. So that is very simple, right? So it's a simple utility. But how many of you are aware about extending this Kubernetes plugins? Kubernetes kubectl with the help of writing the plugins. So there is a way to extend the capability of kubectl. If you go and see, if you type kubectl here, you can see a lot of things available. But think like I have logged as Jasmine user and PG have logged as PG user. And think like if we are having a capability in Kubernetes kubectl, in order to see who am I, that means in which user am I logged into the cluster. So that's a utility which is extending kubectl power, right? So that is what we are talking here. We can add complex behaviors of Kubernetes or Kubernetes ecosystem or the supporting activities which is needed for any organization or for any developers. So that means we can extend kubectl. And we can write this using very simple scripts even, and we can use any programming languages of to extend kubectl. And if someone is worried about the list of available plugins, you can see the list of available plugins using kubectl plugin list command. It's very easy that we can see the list of plugins available. There are already built around 200 plugins available in the kubectl extensions that can be found using this link. This is a repository for storing the plugins. So and also Crew is a tool which can help us to install any plugin. So it's a utility for help us to install plugins which is already available. And for the sake of demo, I have extended kubectl with the help of a plugin which I have written. You can find the source code. It is written in Golang. You can find the details of it from my public repo, that is, kubectl breaking news. Don't think that it is extending the capability of Kubernetes, but it is just, I'm a developer and I fed with a lot of workload activities which I have done for the day. And suddenly I thought that I want to see what is happening outside world. I want to see the breaking news from the kubectl itself. And I have written the plugin, to fetch the latest technology news from the outside world using the kubectl. Let me show that. I thought that I am okay with my trade. Everyone can tell. I'm not sure whether the demo will work because I have switched my personal system, but I will try. Okay. So you can see here. If you see here, I have put it for one of the plugins which is got installed. I hope everyone can see the screen. Okay, so you can see here the available list of plugins which is installed in this particular system, and one of that is breaking news. That is a plugin from my end I have installed here in this system. So I would like to see what is the breaking news. Yeah, you can see here, right? So I have extended the capability of the kubectl to see or to query the latest technology news, since I have fed up with my lot of workloads. So this is how we can extend. This is not like extending Kubernetes, but this is what I'm trying to communicate, that we can extend kubectl in such a way that with our flexibilities. So you can see the source code from my public repo. It is for open source with Apache license. Let's see. I think he is supporting it.
So in this spec, we have a deployment name and the replicas, and in the status, available replicas, which means the number of replicas we requested is in the spec. Actual replicas will be stored in the available replicas. So the way we apply it is, apply this manifest file to create the custom resource definition, and in order to create, once that is done, we can create resources of this kind. This kind is foo. So foo kind we can create using this manifest on the right. So it's that simple manifest that comes in the custom resource definition here. It has two fields, a deployment name and replicas. So for the sample purpose, the way the CRD is used, it will track a deployment and make sure that the number of replicas specified is available or is configured for that deployment. That is what the sample deployment will do. So if you want to change the number of replicas, we can actually go through the CRD. Now, a CRD, that is, the data structure or the data associated with that resource. Now, it needs that logic, the controller logic, to ensure that the specification we requested is actually ensured. So, controller is going to be that piece of code that ensures that the spec or the desired state is actually maintained. So this is a custom controller which I took from the Kubernetes code base. It's a sample thing. I just wanted to mention two things. When we are writing Kubernetes client, API client, there is an SDK already provided, client Go, and this controller is also written using client Go. You can see that is what's in it's Golang. The source code is in Golang. How many of us are familiar with Golang? Yeah, if you are, but it's quite simple to read, right? If you're familiar with programming, it's like C or you should be able to read it. And first one is the import sections, and the key things just wanted to mention. In here, we would connect to the Kubernetes API server in the first section, which is what it does by loading the configuration, which is the kubeconfig file. And then Informer is another thing. When I said the controller actually ensures the desired state, the way it does is it actually keeps track of the changes or changes to that resources. So controller keeps track of the resource, the changes happens to all the changes that happens to that, and at every point it watches and checks if the desired state is actually met. If not, it has to take an action, right, to make sure that the desired state is met. In this case, the watching part is actually done by something called informer, shared informer. Kubernetes has a mechanism called watch, an API system called watch endpoint, and shared informer is the client-side implementation. It makes use of watch and maintains a cache of objects. So I'm just not going a lot into that. But first, in that first thing, that's what it was doing. It connected the API server, and then the informer or the watch part was there. And if you look at the control definition, you can see the informer is being configured to install the event handlers. So it is specifically monitoring for those resources, in this case the deployment and the full resource that we create, the sample one. It is watching for changes to the full or the custom resource as well as the deployment in these two lines here. Okay. And when a change happens, it actually eventually goes on and checks. The case in our case was the number of replicas. So it's actually checking for the replicas here and updating deployment that is associated with it here. So this is that reconciliation loop or reconciliation logic where it actually ensures the right desired state is actually ensured. So we saw that we have a custom resource and a controller associated with that. So it's a typical pattern. Like whenever we define a custom resource, mostly there is going to be a controller associated with that to ensure something, right? So it's a pattern, and that pattern is right down here. It's called operator pattern. It's called operator because whenever we have a custom resource, the controller logic actually would ensure the operational knowledge. For example, deployment, it has to be maintained in a certain way. So that's an operational knowledge that is maintained by humans usually, but it is embodied in this controller. So that's why it was called operator. Now we already saw a controller and a custom resource together. They can be called an operator, although it doesn't implement a lot of meaningful stuff here. We could have operators like take backups of systems when we have an upgrade and stuff like that. And there are already tools like KubeBuilder and Operator SDK which can actually generate the code for control and a CRD. So those are tools we can use to generate the code. And Operator and Helm chart also actually deploys things, but it looks similar in certain aspects. But what is different in Operator is that it has some operational knowledge. Helm chart mostly deals with the packaging and deployment. So that was one aspect in there. When we just take a look at the network plugins.
Thank you, Vijay. So before starting this topic, I want to know how many have created the clusters using Kubernetes. I think it's a topic, especially to the cluster admins or mostly the SRE people. But we want to make sure that the we are very much aware about network plugins because whatever things which we have mentioned in terms of extending the Kubernetes is not at all mandatory things. It can be added or it cannot be added. That is as per our recommendations of the organizations or policies of organization. But with respect to network plugins, even if it is an extension, this is like a cannot go without category extension. That means we must have to install or configure any of these network plugins for sure. If you are, if anyone got created a cluster using Kubernetes tool, it's a command line utility to create clusters, which is officially from the Kubernetes project. So if you created, you're pretty sure you're wondering that why I'm not able to get deploy these pods, because definitely when you got created a cluster, it will props for the network plugins. It will definitely look where is my network plugin. It will, each and every Kubernetes having certain directories, that is binary CNI binary directories and certain configuration directory. It will always, when you got installed, it will always look for these network plugins. We must have to install. So definitely we want to make sure that we are aware about this kind of network plugins. There are two categories in that. First one is the CNF plugins and second one is the Kubernetes. We should mostly talking about and aware about CNF plugins because most of these CNF plugins will only enable the cross-node networking. So basically, everyone knows about the basic networking fundamentals of Kubernetes. What exactly we need the networking plugins in Kubernetes. There are mainly four things. We need C2C networking, that means container to container networking. We need port to port networking. We need to expose port to services, that means port to service and service to the external. So even if your code is shared, deployed, we want to make sure that this kind of plugins are installed, otherwise we cannot let our applications to be accessed from the outside. So these network plugins will do certainly do main two things. First one, it will configure the network, then it will configure the routing. So these are the two basic fundamentals of the network plugins, especially the CNF plugins. So CNF plugin is nothing, it's it will follows the container network interface specification. That is standard. That is a common standard. I think it's from Open Container Initiative, or it may be a separated specification or standard. But every of these CNF plugins is following these standards in order to enable the networking in Kubernetes. So basically, it support host port. That means we can even talk with the loopback addresses of the nodes where the pod is running. Other one is the traffic shaping. I think traffic shaping is one of the best known topic for developers, especially because they may need to tweak how the traffic is getting ingressed or egressed. That means getting out to the cluster and into the cluster. So we can make use of these network plugins to make this kind of traffic shaping as well. And I like to share a few of the commonly and widely used network plugins such as Calico. I'm pretty sure that everybody's heard about Calico. Calico is a very wonderful network plugin. It is having a lot of extensions. Weebnet is one of the other commonly used one. Other one is Plan and finally Stables for simplicity. And there are new things. One is from Cilium and other one is Anglia. That is basically from the VMware Anglia. So I'd like to share one more insight here. Basically, Calico or any of the Kubernetes plugin by default, it uses the kube proxy and it will make IP tables routing rules to be created on the behind the scenes when you got created a service. That means it should be routed, as I already told, we need to let the port to be routed to the service. So this kind of routing rules will be happened with the help of these IP tables. And this network plugins will take care of creating that rules for us, because it is nearly impossible for a human being to write this kind of routing rules every time we are creating these services. So that is what it is famous and good for. But we are having a new thing as well called eBPF. That is extended Berkeley's packet filter. We can let eBPF modules to be route our routings. That means instead of using the IP tables, we can make use of eBPF. It's a packet filter tool which is mostly in the Linux boxes. So the CNM is famous for that. Basically, CNM let their outing happen through that routing happen through the eBPF filter. The good thing with that is, it is not making any rules. Instead, it is writing this routing in the kernel space. That means it is directly reading the data path in the kernel with the help of some sandbox programs. So this is much introduction to the network plugins. I hope we have completed. Yes, we have completed our topics. It's a time for you to ask the questions. I can pass the mics to each and everyone.
Actually, you explained about the CRDs. So, can you give one practical example where we need them? So, actually, the replica set control is actually handled by Kubernetes itself can handle. But kind of a practical scenario where we can introduce a CRD in our practice.
For example, we have a custom application or our application we want to install, and as part of that we need a schema migration, right? So we have deployed this, but before the deployments actually happen, maybe we want to do some schema migration or a backup or setting up the system. So that may be one example that you can use. But if you look at if you are using any custom installation such as certificate manager, right, which automatically issues certificates, those all comes with a lot of CRDs like that. Does that answer your question?
Means those are comes internally or we
Yeah,
have
they come with.
they come for internally. Like
Yeah.
as you said, an operate after that you said that operator. So operator is actually kind of an example like if you operate the same operator what we are referring to that. Can you connect the operator as a operator like a controller and the CRD?
Yeah.
So it means custom interface will be creating some custom interface, right? So that is actually kind of it's a kind of active operator. So that is kind of a CRD and custom controller which is managed by SQL itself. That's what we are referring.
Yeah.
Any more questions? More questions? Okay, thank you, Bridget and Justin, for the wonderful session. We shall the developers here for the tips which they have shared for making their life easier. And based on my experience working with Bridget and Justin, I know they've explored more into the capability of Kubernetes. You can very well reach out to them to get more insights. They will be here around. You can catch one of them. And next we have the second round of quiz. Alexei will be taking.
ഒന്നുകൂടെ നമസ്കാരം. സമയത്തിന്റെ അവൈലബിലിറ്റി കുറഞ്ഞതുകൊണ്ട് നമുക്ക് 10 ക്വസ്റ്റ്യൻ വേണോ 5 ക്വസ്റ്റ്യൻ വേണം? അതായത് ഒന്ന് പറയുവാണെങ്കിൽ 10 ക്വസ്റ്റ്യൻ വേണം 5 എണ്ണം മതിയോ? പറയാമോ? 10. അപ്പൊ ആർക്കും ഒബ്ജക്ഷൻ ഒന്നും ഇല്ലല്ലോ? 10 തുടങ്ങിയേക്കുവോ? സോ സ്ക്രീനിൽ ലിങ്ക് വന്നിട്ടുണ്ട്. നേരത്തെ പോലെ തന്നെയാണ് ഇൻസ്ട്രക്ഷൻസ് എല്ലാം. അതായത് ഫോൺ എടുക്കുക, kahoot.in പോവുക, ഈ പിന്ന് ടൈപ്പ് ചെയ്യുക. just go to the domain kahoot.it, type the AD 1775895. സമയമില്ലാത്തതുകൊണ്ട് എല്ലാവരും പെട്ടെന്ന് ടൈപ്പ് ചെയ്ത് കേൾക്കാം. So like 10 seconds left to start the game. So please hurry up. So we are going to start last 2 seconds, 1 second, and here we go. So here comes the first question. Which tool can create a local development cluster? Ten seconds. 10 seconds. 35 got it right. So after the first question, here comes the second question. Which one of the following helps to set up a cluster autoscaler for adding capacity as per demand? Ten seconds. Time's up. 17 got it right. Abdul Hafiz leads. We are moving to the third question. Which one of these is not a cloud computing pricing model? Ten seconds. Still, Abdul stands at the first position. We are moving to the fourth question. Defining a service without a selector can be achieved using which of the following? Ten seconds left. Still, there is no change in the first position. What is the tool to install Kubernetes plugin available? Ten seconds. Time's up. Still, there is no change in the first position. Abdul leads with 4,623 points. Moving to the sixth question. It's a true or false question. Only one Boolean can be specified at the port level. Is it true or false? 10 seconds left. Got it right. Still, there is no change in the first question. Moving to the seventh question. What is the output of this program? Output. Five seconds. Thanks, sir. Told got it right. So the chance stone comes to the first question. Eighth question. What are the advantages of Go? Ten seconds left. What are the advantages? 41 got it right. Still, Charles John leads. Second last question. Kubernetes is returning dash programming language. 10 seconds. Here comes the last question. Which of the following activities of generic process framework delivers a feedback report? Five seconds left. 18 got it right. Third position. Shenjula. Congratulations. Second position, Akil Office. Congratulations. And the first position goes to Charles John. Congratulations. So thanks for all the participants for coming and attending the event. Thanks.
Thank you. Congratulations, Nicholas. Second for the first round, it is reliving. And third prize goes to Charles John. Thank you. And for the second round of quiz, the first prize goes to Charles John. And second prize goes to Abdul. And third prize was Sinju. I would like to call out Tijish to hand over the gift for organizers. And Alexi, thank you for your support. Amal, thank you for your support for organizing this event. Thank you. And for a lot of handing it over.
ഔട്ട് ഓഫ് ടൈം പോകുന്നതിന് മുമ്പ് നമ്മുടെ പരിപാടി ഇത്ര മനോഹരമാക്കി ഒരു കേന്ദ്ര ബിന്ദുവായിട്ട് ഇന്ന പൗരച്ചേച്ചിക്ക് ഒരു ഉപഹാരം സമർപ്പിക്കുന്നു.
basically ഒരു 6 months മുന്നാണ് ഞാൻ കഥ പറഞ്ഞ് നിങ്ങളെ ഒരു ബുദ്ധിമുട്ടിക്കുന്നില്ല. പക്ഷെ ഒരു 6 month ഒരു 1 year മുന്നാണ് ഞാൻ ഈ റിക്വസ്റ്റ് വരുന്നത്. ഞാൻ കുറച്ച് CNCF കോൺട്രിബ്യൂട്ട് ചെയ്യുന്നുണ്ട്. അപ്പോൾ അത് കാരണം ഞാൻ ജസ്റ്റ് ഒന്ന് എൻ്റെ ഒരു പാഷനൊക്കെ പോലെ ഞാൻ ജസ്റ്റ് ഒരു ചാപ്റ്റർ ആണ് റിക്വസ്റ്റ് എടുക്കും. അങ്ങനെയാണ് ഇത് അപ്രൂവ് ചെയ്ത് കിട്ടുന്നത്. ആ സമയത്ത് എനിക്ക് തോന്നില്ല ഇവിടെ വേറെ CNCF ചാപ്റ്റേഴ്സ് കയറാൻ നോക്കുന്നത്. എനിക്കൊന്ന് കൊച്ചിയായിട്ട് ഒരു തുടങ്ങിയതാണ്. പക്ഷെ ആക്റ്റീവ് ആയിട്ട് വിജയിച്ചാണ്. ഓക്കെ, സോ പക്ഷേ ഇത് ഇത്രയും സക്സസ് ആവുന്നതിന് മെയിൻ റീസൺ എന്ന് പറയുന്നത് ഒരു കമ്പനിയുടെ വിഭാഗമുണ്ട്. അതാണ് സ്ട്രാറ്റജി. എബിനൊക്കെ ഓപ്പറേറ്റ് ചെയ്യുന്ന ഹെഡ് ഓപ്പറേഷൻ ആയിട്ടുള്ള ഒരു കമ്പനിയാണ്. അവര് എൻ്റെ അറിവിൽ ഫസ്റ്റ് Kubernetes സർവീസ് പ്രൊവൈഡറാണ് കേരളത്തിലെ. സോ ഐ വിഷ് ഓൾ ദി ബെസ്റ്റ് ബിക്കോസ് ഇതിലെ എല്ലാ കാര്യങ്ങളും മോസ്റ്റ് ഓഫ് ദി ട്രാൻസാക്ഷൻ done through strategy. So they have done a very wonderful job, especially Vinayak, CEO of strategy, and all the associated members. Very much thank you for that because we were a dream I have 1 year minute. Now it came to the reality. So I need only continue on research area. And second thing, especially the organizers, AP, Bhavida and Vinaka, they shaping support with successful ഈ മുന്നോട്ടുള്ള ഈ ഓർഗനൈസേഷൻ ആണ്. അതിലുപരി നിങ്ങളുടെ നമ്പേഴ്സ് നമ്പേഴ്സ് ഇത് ഫസ്റ്റ് ഇവന്റ് ആണ്. ഫസ്റ്റ് ഇവന്റ് ടു ബി ഓപ്പൺ ഞാൻ ഇത്ര എക്സ്പെക്ട് ചെയ്തിട്ടാണ് ആൾക്കാർ വരുന്നത്. പക്ഷേ ഐ തിങ്ക് വി ഹാവ് ഡൺ എ വെരി ഗുഡ് ജോബ് ദാറ്റ് വി ഗെറ്റ് lot of people like you. ഞങ്ങളിവിടെ ഇന്ന് സ്പീക്കേഴ്സ് സംസാരിച്ചത് കൊണ്ട് ഞങ്ങൾ മിടുക്കന്മാരല്ല. ഞങ്ങൾക്കറിയാം ഇത് നല്ലതായിട്ട് സംസാരിക്കാൻ കഴിവുള്ള ആൾക്കാർ ഇതിൻ്റെ ഇടയിലുള്ളതുകൊണ്ട് മെനി ടെക്നോളജി ലീഡേഴ്സ് ഉണ്ട്, നല്ല ഡെവലപ്പേഴ്സ് ഉണ്ട്. ഈവൻ എന്നോട് വർക്ക് ചെയ്യുന്ന നല്ല ഡെവലപ്പേഴ്സിനാണ്. So definitely this is a platform for you guys to share your knowledge to the people or to the community levels. So in future, so ഞാൻ നിങ്ങൾക്ക് ഞങ്ങളൊരു ഫോം ഇതിന് ശേഷം അല്ലെങ്കിൽ ഈ 1 week നിങ്ങൾക്ക് സ്പീക്കറായിട്ട് ജോയിൻ ചെയ്യാൻ ഇഷ്ടമുള്ളവർ നിങ്ങളുടെ ടോപ്പിക് സജഷൻ അതോടൊപ്പം തന്നെ നിങ്ങളുടെ സ്ലൈഡ്സുമായിട്ട് ഞാൻ സമീപിക്കുവാണെങ്കിൽ അപ്കമിങ് ഈവെന്റ്സിൽ നമ്മൾ എന്ത് ചെയ്യും നിങ്ങൾക്ക് അതിനുള്ള അവസരം തരുന്നതായിരിക്കും. അഥവാ ഏതെങ്കിലും റിജക്ഷൻ അല്ലായിരിക്കും, ഒരു പക്ഷേ അത് ക്യൂവിലായിരിക്കും. ബിക്കോസ് അതുപോലെ നമുക്ക് റിക്വസ്റ്റ് ചെയ്യാൻ സാധ്യതയുണ്ട്. ആൻഡ് ഒരു ഫ്രഷർ ആണെങ്കിലും ഒരു എക്സ്പീരിയൻസ്ഡ് പേഴ്സൺ ആണെങ്കിലും ഈക്വൽ പ്രയോറിറ്റി നമ്മൾ തരുന്നതായിരിക്കും. സോ അതാണ് ഒരു ഫസ്റ്റ് ഒരു നെക്സ്റ്റ് കാര്യം. അതുകൂടാതെ തന്നെ ഇതിന്റെ ഒത്തിരി സപ്പോർട്ടിംഗ് ആക്ടിവിറ്റീസ് എസ്പെഷ്യലി വർക്ക് ചെയ്ത സ്ട്രാറ്റജിയിലെ എംപ്ലോയീസ് ആണ്. അവരോട് എൻ്റെ പ്രത്യേകം വന്നു. അതുകൊണ്ടാണ് ഇതിനെ നല്ല രീതിയിൽ നടക്കാൻ പറ്റുന്നത്.
Justin Bhargava പോലെ way forward we will be organizing such events, sessions and all. Whoever is interested, please get in touch with any of us, and we will be sharing the Slack channel details, the social media links, everything via email soon. So thank you everyone. Yeah, we will publish all the links where you can actually see the updates from our end. Thank you all for your time. ആർക്കെങ്കിലും ഫീഡ്ബാക്ക് ഷെയർ ചെയ്യാൻ ഇൻട്രസ്റ്റ് ഉണ്ടോ so that we can improve for the next time? Please share feedbacks. If not now, you can send it to us.
Good afternoon. So, to be honest, I was in Bangalore. I used to do a lot of meetups, and when I came back to Trivandrum, one thing I was missing was these kind of meetups. And only one venue where we used to see such kind of meetups was with Pratibhan. I believe you might be knowing him, and that usually happens once in a month or so. But when I saw this CNCF meetup here, I was very surprised to see from where this is coming in. I looked into the details. One thing, I was so happy to see that such events are happening here in Trivandrum. Me, a native of Trivandrum, I was so overjoyed to see this kind of happenings. These kind of events are happening here, and I would look forward to see these kind of events happening so frequently. And one thing I want to share is not many people are aware of this event that has happened because usually I look at the meetup and stuff like that. I never saw this ad coming up anywhere else. So I would recommend to reach out to more folks. Probably you can share the Technopark forums, or you can put in some of the Trivandrum forums. I believe we have a pretty good response here. So hopefully we will get more participants, and looking forward for the same. And once again, thanks for all these participants. Take care of this event. Thank you. Thanks everyone. You can call me Shah.
Thank you, Shah. And I just wanted to mention two more things. We have with the DevOps on another platform. They are into DevOps sessions. So one another channel you can get into. And one more thing is AWS user group also.
Actually, we are here to and we have a user here in Trivandrum also. And this guy, G2, he is the link between all of us. And he started Clubhouse community DevOps and added all of these guys in one channel. Then we started discussing about these kind of features. And eventually, we took this one and started this CNCF Trivandrum channel.
Thank you. Normally, even we could publish